to the Google Colab notebook, and I'll show you how to do it in practice. Right. So first of all, we import all the libraries. So previously in the first session, Vimukthini showed you how to import libraries, the libraries that you need. And she also showed you how to load the data set. I'll also get the same data set. Okay, so it's still loading. Yeah, okay, so this is our data set. And now we are going to fit the simple linear regression line. So as I told you earlier, our y variable is going to be the temperature average. And these are just the unique values. I'm just trying to get a feel of the data, so I'm just looking at it. So let's just check the distribution of our y variable. So we now know how it looks like. So I'll be using Plotly for all the visualization, because we can see these interactive charts here. So I mainly prefer Plotly because of that. And okay, let's see what our x variable is. Let's as an example, let's just take the dew point average as our x variable. Yeah, so previously Vimukthini cleaned all the data, and I won't go in detail to the cleaning part, so I'll skip this step and I'll just visualize the x variable. Right, so now we have a little feel of the data. So we see that this is how our x is distributed, and we saw how our y is distributed. And now we are going to visualize our x and y variables. We are going to plot a scatter plot between our x variable, the dew point average, and y variable, temperature. And we draw a trend line using OLS. So basically, we have fitted our first simple linear regression model. And this is the one that is shown in the black line. Okay, so now we have this equation. It's easy, right? So now we have this equation. So where we get the temperature average, and we have our beta naught as 22.69 and beta 1 as 0.84. So, okay, now previously I talked about this error. And how do we find what is this error? So let's assume that our dew point average is 40 somewhere here, and we can drop this here and see these are our values when the dew point average is at 40. So let's predict the temperature using our regression line, and we have a predicted temperature, that's 56. And the actual temperature, say we are considering about this point, and it's 67. So the error is just the difference, and we can compute the error as the difference of the actual value and the predicted value. Okay, so now I showed you how to draw, how to basically do a regression using Plotly. But if you want to like hand code it, and if you want to find the beta naught and beta 1, these are our equations that you can find. So I'm not going into the details of the equations. I'm just hand coding it using NumPy. So in NumPy, you can use the correlation coefficient. So we can multiply the correlation coefficient by the standard deviation of y, and we can divide it by the standard deviation of x to get the beta 1 estimate. And let's see if that's the beta 1 we get from the previous value. So it's 0.84. It is the one that we got from the fitting as well. And for beta naught, it's the y bar, that's the mean of y variable, minus beta 1, the estimate that we got from here, times the mean of x. Okay, so now we have both beta 1 and beta naught, and we found it using our hand coding method. So the next question is, how do we predict? Like I showed you here as well how we predict, but I just wanted to show you how we can use the values that we computed here, beta 1 and beta naught, and make the prediction. So let's say our new x value is 45, and we know the beta naught and we know beta 1. So our y hat is going to be 60. Okay, so that's our simple linear regression. If we want, there are many other ways to model it, and we can use stack models. So when we use stack models, we need to remember that we have to add a constant to our data frame that we use. So we use df1 viewpoint average, just that variable, and we have to add this one column for constant before we put it to the model. So in stack models, we can get OLS, and we can put our y variable, the temperature, and for x at c, that means we have one column with the dew point and another column with for constant, and we fit the model. So basically we get the same result. We have the constant here 22 and the dew point average as 0.84. So I just showed you three methods that we can do a simple linear regression. Right, so why did I show you this? Because when we use stat models, we can get this nice description of the evaluation measures like CAVC R squared, and then there are different tests that it automatically conducts. So we get everything nice here. But it's up to you to select the model, select the way that you want to model.